Hi, I'm Miss Haley with the Huntsville-Madison County Public Library. And for today's STEM experiment, we are going to be learning about capillary action and cohesion and adhesion, which I know sounds like a lot, but it's actually very, very simple, and I'll talk about that more as we're doing the project. So for this project, it's a very simple project. You only need a couple things. You'll need a pair of scissors. You don't really have to have scissors. You can tear the paper towels, but scissors help. You will need some paper towels. If you're going to do it exactly the way I'm doing it today, you're going to need some cheap paper towels and some pricey fancy pants paper towels. So I have just an off-brand cheap paper towel here, and then I also have a Bounty, I think, or Brawny, I'm not sure, but a more expensive, thicker paper towel. You do not have to do it that way. You can do one or the other and just do half of this project and still get the effect and see what happens. But we're setting this up as an actual experiment today rather than a project. So to do that, you will need both types. So expensive paper towel, cheap paper towel. You'll need some water, and you will need 6 plastic cups or clear glass cups. The important thing is that they are clear. You can use glass cups if you're at home. You probably just have glasses lying around. I don't, since I'm at the library, but just some clear cups. You'll need 6 if you're doing it the way I'm doing it. If you are not, if you want to do half, just do half and do 3. And you are going to need some food coloring. You'll need red and blue and yellow. So you need your primary colors. Those are your 3 primary colors, because we're also going to do a little color mixing today with the end result of our experiment. So if you are doing a half project, you only need 2 of these colors. So just pick which 2 you want, pick which color you want to come out at the end and go with that. So to start out, we're going to set aside 2 of our cups, and we're going to keep 4 of them. Get this more in frame here. And 2 of them are going to have blue in them because I'm doing both of my projects with blue. So I'm going to put, let's say 7 drops of blue in each one. Maybe 1 more in there. I think I lost count. You really don't have to be specific with that. And then in this one, I'm going to put red. Oop, that was 8. Oh well. And then in this one, I'm going to put yellow. 2, 3, 4, 5, 6, 7, 8. But why do I just want to do 8. I'm going to put 1 more in each of these so that they'll at least be even. I don't know why I want 8. All right, so we've got our food coloring. These 2 cups are going to be a pair, so that will make red and blue make purple. And then these 2 cups will be a pair, so that's blue and yellow will make, what color? What color? Green. All right, and we're going to set these up. Try to set them up so they're in frame for both of you guys. Both of them? Yep. Okay. So what we're doing today is we are going to use paper towels to illustrate how sticky water is. Do you guys think about water as being sticky? So go ahead and pour some water in each of your cups. Fill them each about halfway to start, just to make sure I have enough water here. You can fill yours up more. As long as you're going to watch your project, you need to check on it frequently if you fill them all the way up. So water is actually pretty sticky. We don't think of it as being sticky because we use water to wash ourselves, to wash things off our hands, to wash sticky things off our hands. But water is actually pretty sticky. I'm going to leave a little bit so I can show you guys. So go ahead and just stick your hand in some water, not your colored water, just regular water. And take it out. You'll notice, what do you notice? It's still on your hand. It doesn't just slide off. It sticks to your hand, and that is adhesion at work. So water really likes, number 1, to stick to itself. It's cohesive. Cohesion means it sticks to itself. So similar molecules, water molecules sticking to other water molecules. And it really likes itself. It wants to stick to itself. It also likes to stick to other things. So things like your glass or your hands, your skin. It likes to stick to other surfaces. It's attracted to them. The molecules are attracted to those other surfaces, and that is called adhesion. And capillary action, so when you put a paper towel, I've already cut one piece of paper towel here. When you put a paper towel in some water, let's do it in my blue, so you guys can see what happens to that paper towel. Well, if I just dip the very end, it soaks it up. But you can see it's traveling up my paper towel. And that is capillary action. So capillary action sucks water up and through something. And it does that by working against gravity. And to work against gravity, it has to rely on water's natural cohesion and adhesion. So the water sticks to itself and to the surface, in this case, the paper towel. And that helps the capillary action work against gravity and pull things up. And capillary action is how plants feed themselves. So plants, their roots soak up that water and nutrients and move it all the way up to the tippy top of their leaves through capillary action. So paper, though, has a finite point where you can't soak anything else up. So we're going to put our third cup, between each of these. So that's our empty cup. It should be completely empty and clean. And this is going to help us see when our paper towel reaches saturation. So once the paper towel has absorbed as much water as it possibly can, it is going to hit a point that we call saturation. And what do you think happens once your paper towel is saturated? What do you think happens? It's going to start to drip. So if you've ever soaked a paper towel to the point where it can't hold any more liquid and you pick it up, it drips all over your floor. So that's what's going to happen. And when it drips, because the capillary action has created a flow of water, it's going to drip into our other cup. And I will show you how. But first, I want you to take your paper towel, and whatever side is the shortest side, I want you guys to cut a strip. We're using our cheap paper towel first. So I want you guys to cut me a strip. Let me see how long I need it to be. Is that going to be long enough? I'm not so sure. And we are going to take our strip and we're going to dip it all the way down into the blue and over. I'm going to cut it off a little bit. The shorter your strip, the quicker this works. We've done this project before, and I had bad results because I wasn't moving fast enough. All right. So we're going to drape it in over to there. Then we're going to do the same thing on the other side. Let's see, I only cut off a little tiny piece there. You may not even really need to cut off any with a cheaper paper towel. Don't let it slide all the way into your water. Like that. So you have one each of the paper towels in your colored water with the dry ends going into your clear cup. And what we're going to see is the paper towel absorbing the water and eventually dripping down here. And you should see some color mixing happen. And we'll switch to a time lapse here in a minute because it does take a while. This does not happen immediately. It can take some time. So now we're going to set up our other part of our experiment. We're testing which paper towel does it better. So I'm going to write cheap on this one. I'm going to put it right here just so I know. That's also why it's different colors. And then we'll write pricey on the other one, and we'll set it back behind here. I'm not sure if you can see that really, but that way my two projects are labeled and I can't get confused. So now we're taking our expensive paper towel and we're doing the same thing. We're cutting a strip. I'm going to cut off just a little tip, so it's about the same length as my other one, and I'm going to stick it down into the blue and over. Be very careful that it doesn't slip all the way into your water. It really kind of wants to do that at first. So cut a second strip and set it into your yellow. See, it really wants to suck it into that other cup. There we go. So what I've done to keep it from sucking down is I've pulled it back up a little bit so that the wet part is right on the edge there. So now we're going to let it sit, and we are going to let it absorb up the paper towel through capillary action and presumably down to the other end. Once it's fully saturated, it should start dripping and we should see some color mixing. So what we are testing today is which paper towel, A, works fastest, and B, let's see if there's a difference in quality. Like, does it work better? Do we get a better color, a deeper color? We're just going to see what's the difference between these two paper towels in this experiment. And I am going to switch over to time-lapse now, and we are going to see what happens. Okay, so it has been 2 hours and 40 minutes, which is just a random amount of time that I had to run this experiment today. You do not have to do it that long. You could do it longer if you wanted to, see how much you could get to transfer into the middle cup, but you don't have to do it that long. You can just do it until you start to see results. It does take a while. It took maybe about an hour before we really started to see dripping and color mixing there. We had some drips, I think, before that. We had drips pretty quick, actually, but it took a while to get enough to color mix. So let's look and see what we can observe from our experiment. I'm going to set this paper towel over here so I can set my wet strips, because we're going to go ahead and stop the experiment. And to do that, we're just going to take out the paper towel strips. Oops. Not tip over my whole cup. That would be bad. We're going to lay them over to the side, and that stops the flow. That stops our experiment. And you're going to observe what we have. And we could have some fun with those strips. They're already color mixing just right there. That's kind of cool. So our cheap paper towels were in this front one. And we have a very dark purple liquid, and you can see on the side where it was dripping down the side where the paper towel sat, we have our blue and our red, and it's a very dark, I would say almost violet color. The blue definitely was stronger than the red a little bit. I had the same amount of each, but if we wanted more of a balanced purple, we might have needed more red in there, because this is a pretty blue purple, very, very dark. And we have, I would say, about 1/2 inch of liquid in this cup. So we have a good amount. And I do know that I observed this as the time lapse was filming. We had definitely more, we had drips sooner in this cup with a cheaper paper towel. And that's probably because cheaper paper towels, if you observe the texture, if you still have your paper towels, you can kind of feel of them. The cheaper paper towel is much thinner than the more expensive paper towel that is a lot thicker. And that's something that paper towel companies really advertise, is that they are absorbent. They can hold a lot of liquid before you have to use them, so that you don't have to use as many. So I definitely think that proves this, because the cheap paper towel was saturated much quicker than the more expensive paper towel. And because of that, our experiment worked better on the cheap paper towel, but if you were cleaning up a spill, you'd probably do a better job or have to use less paper towels with a more expensive one. So we're going to set aside our cheap paper towel cups. So we had a 1/2 inch there. I'm going to leave that one on camera. And let's look at our pricey paper towel cups. So our pricey paper towel cup, we do have a really nice vibrant green color here, but we have probably not even 1/4 inch there. I would say that's a little bit less even than 1/4 inch. This one might be 3/4 inch, not 1/2 inch. Ooh, I have a ruler. You can look. Yeah, it's a little bit more than half an inch in here. But anyway, that doesn't really matter. That's just interesting. So we have much less. If you guys look at these side by side, the green, remember, was our pricey paper towel, and the purple blue was our cheap paper towel. We have much less liquid in this one. So we definitely, it took longer on the more expensive paper towel. And because of that, we have less liquid because it didn't reach that saturation point as quickly as the cheap paper towel did. So that is the results of our experiment there. And I hope you guys had fun. You can do this in a lot of different ways. You could even set up just a rainbow of colors where you alternated. You could do a lot of fun things with this project. But I hope you guys had fun, and I hope you guys learned some interesting things today. And please feel free to join us again for our STEM videos. They are every Wednesday here on YouTube, and we would love to see what you're doing, whether you're doing this experiment or your own experiments at home. We would love to see that. You can share them with us on our Facebook page, which is Huntsville Madison County Public Library. We would love to hear from you. Thank you, guys.